Hey everyone, welcome back to BugNoJutsu, the place where we debug, decode, and dominate coding problems. Today's video is all about a deceptively simple LeetCode problem that hides a smart trick behind it, the longest harmonious subsequence. Problem number 594. We'll walk through what the problem is asking, decode a key example, and understand how we can solve this with optimal performance. Let's get right into it. The problem defines a harmonious array as one where the difference between the maximum and minimum values is exactly 1. Now, given an integer array nums, we need to return the length of the longest harmonious subsequence among all possible subsequences. Important to note, a subsequence doesn't need to be contiguous. We can pick any elements from the array as long as we maintain the order. You do not need to return the subsequence itself, just the length. The subsequence does not need to be continuous. You can pick any combination of elements from the array as long as the max and min differ by 1. Let's go over an example again. Input nums equals 1 3 2 2 5 2 3 7. Now go through the array and think, which values are close to each other by just 1? Here, you can spot that the numbers 2 and 3 appear multiple times. Let's try picking every 2 and every 3 from the array. We get 3 2 2 2 3. The minimum is 2. The maximum is 3, difference is 1. This is a valid harmonious subsequence. Its length is 5, which is the maximum possible for this array. So the final output is 5. We are not being asked to generate all possible subsequences. That would be super inefficient. Instead, we are being asked to efficiently find the longest group of numbers from the array that only includes 2 values, some number x and x plus 1. And has the most total elements. This means we want to group values by their frequency and just compare adjacent keys, x and x plus 1, to find the best pair. To solve this efficiently, we use a very powerful trick, frequency counting. Here's the plan. First, we count how many times each number appears in the array. This gives us a quick way to know how many 2s there are, how many 3s, and so on. Then we loop through every unique number. For each number, we check if the number just above it, that is, number plus 1, exists in our frequency map. If it does, then number and number plus 1 can together form a harmonious subsequence. So we simply add their counts and check if it's the longest one we've seen so far. By repeating this for all keys, we eventually find the longest valid subsequence. The beauty of this approach is its efficiency. Counting all elements takes O(n) time. Checking each unique number also takes O(n), in the worst case. So the overall time complexity is O(n), linear time. Space-wise, we store counts of numbers, which also takes O(n) in the worst case. And we do this without sorting, without brute force, and without generating subsequences manually. That's what makes it optimal. This problem is a great reminder of how frequency maps or counters can simplify complex-looking problems. A lot of people fall into the trap of sorting the array and scanning for adjacent values. But with frequency maps, we solve it faster and more elegantly. So whenever you encounter problems involving relationships between values, especially differences like +1 or -1, always consider using a counter-based approach. That's all for today's breakdown of longest harmonious subsequence. If this helped you understand the logic clearly, don't forget to like, subscribe, and share the video with your fellow coders. Drop a comment if you have any questions or want me to cover a specific LeetCode problem next. This is BugNoJutsu, signing off, and I'll see you in the next one.